When you order a pizza, do you sit around and wait for it while someone's making it and delivering it? Or do you just live your life? Asynchronous JavaScript. Hello, this is episode 11 of a 10-part series. Wait, what? So I made this 10-part series called 10 Things JavaScript Developers Should Know But Probably Don't. It did well enough that it inspired me to do 10 more. So I asked you, the great people of the YouTubes, to tell me what you want to see next. And there were a lot of great suggestions, so thank you all. I've kept track of all of the suggestions, so keep them coming. But an overwhelming number of you wanted to hear about asynchronous programming. So as promised, promise. Here it is, episode 11, Asynchronous JavaScript. Today, we will cover synchronous programming first to understand what that is. Then we'll talk about why it's not enough and the need for asynchronous programming. Then I'll show you how you've been writing asynchronous code this whole time using callbacks. We'll talk a little bit about Callback Hell and what that is. Then we'll quickly chat about promises and take it from there. As always, the most important question when learning something new, why? Why do I need any of this? So we'll get to the why then, of course. Let's begin. When we talk about asynchronous programming, we are usually referring to a situation where a part of your code depends on another part of your code or process, like waiting for a backend call or a user click event. A reminder on how JavaScript runs at a fundamental level. JavaScript runs top to bottom. Any code you write executes one line at a time. The key here is that JavaScript waits for each line to execute and do what it needs to do before going to the next line. This needs to happen because presumably each line depends on the line above it or some line that came before it. That's an assumption built into the runner. So take this basic example. I create a variable called pizza and then I log it, right? This is an example of synchronous code. When I run this code, it goes step by step. There are only 2 steps, but it does go step by step. It's really fast, so we think it all happens immediately, but it actually takes a little bit of time for each line to execute before going to the next one. And yes, even the first line, which is nothing but a variable declaration, there's some work involved there. There's memory allocation for the variable, then there's writing the actual string into the memory, and a whole bunch of other low-level computing needs to happen when that one line of code runs. And while all of that is happening, the rest of your code, which in this case is just one more line, is basically paused. We can't console log the pizza variable before it's declared, right? We need to wait, and we do wait. But again, the reason why we don't notice that is because it's not a heavy job for the computer, especially modern computers. So that's a synchronous process. Let's move the pizza logic into a function so it's a little more isolated. Everything runs the same, so no change to the outcome here. This is a function that's synchronous. Synchronous means things happen together in the order they were set up, in a synchronized way, if you will. So keep that definition in mind for now, synchronized. Actually, I'd rather show you than tell you. So here's a way to visualize it. Imagine this gray line is a road, and that's our entire code from start to finish. The purple line is where we are. So we execute the first line of code, which is to create the pizza variable. That happens, pretty simple. Then we get to the point where we call our makePizza function. It takes our attention away a little bit. We leave the main road, go off into the side. The function takes a tiny bit of time, like I said, but it then returns a string, and we assign the return value to the pizza variable. So now we're back on the main road. So we continue, call the console log, and that's it. That tiny bit of time that it took for that function to return the string is so fast that we didn't notice it, right? But it does get us off on a different track for a moment. Well, what if the function did do a big, heavy task? Would we notice it then? Well, pizzas don't just magically appear out of nowhere, right? Well, I mean, what happens when you order a pizza? It takes a little bit of time. Let's imagine a function that actually did enough to slow us down. Our timeline visualization would change just a little bit. The waiting part would grow a little bit to a point where we actually do have to wait for the computer to finish doing what it's doing and then get us back into the main road. So what happens to the app during that time? Let's find out. To the browser. All right, so first things first, let's write and run our existing code, right? So I'm gonna create this pizza variable. Then I'm gonna create a function called, what was it? Order pizza. And I'm going to console log order pizza. Then I'm going to assign this value. Let's see, how do I do this? Nope. Oh yeah, here we are, our friendly emojis. Let's look for pizza. I'm gonna set that to set the variable pizza, and then I'm gonna say console.log pizza was ordered. Right? And then after this, I'm gonna actually call my function order pizza and also console log when we're done, which is eat a pizza. And I'm gonna actually use my variable here. I'm gonna console log my variable. What happened? Why am I missing something here? Nope, we're good. All right. So when we run it, we ordered a pizza, pizza was ordered, then we eat the pizza, right? So let's say ordering the pizza does take some time because that's what happens in real life, right? Let's say it takes a couple of seconds. Let's go back up, create the pizza. I'm gonna do this, whoops. Let's do the let pizza. And so let's say, what would happen if it took actually 2 seconds, right? Set timeout, we'll do a basic error function. And what if it took 2 seconds for this line to execute? Okay, we execute it the same way, order pizza, pizza was ordered, eat undefined. All of a sudden, our pizza is undefined. So why is that? Well, that's because our function took 2 seconds to set the value of pizza to pizza, but the console log didn't wait for it. But wait a minute, didn't we say that in JavaScript, each line waits for the previous line to finish? Yes, and the order pizza function, actually the execution, the invocation rather, this line actually did wait. It was already executed and finished before this console log, the eat pizza, was done. But the eat pizza didn't log the right value. So the runner doesn't wait for the set timeout before moving to the next line. And that's because set timeout is an asynchronous function. It's an asynchronous operation, meaning it's not synchronized with the rest of the code. It's on a different journey on its own. And that's good, right? You don't want to pause everything while the pizza is being made. So back to my original question in the beginning of the episode, when you order a pizza, do you just sit around and wait for the delivery person to show up? Or do you just live your life? Maybe you go call a friend, you go do some laundry or watch TV or write some code. Do whatever you need to do until the pizza shows up at the door, right? That makes more sense. Same thing here. We want some of our code to continue no matter how long the order pizza function takes. Say right after I order my pizza, I want to call my friend Qoli because I haven't talked to him in a while and I miss him. In real life, I can call Qoli as soon as I order the pizza. I don't have to wait for the pizza guy to show up before I call my friend. In fact, when the pizza's here, Qoli, I don't want to talk to him anymore. I want to eat my goddamn pizza. So waiting for the pizza and calling Qoli are two separate sets of events that can happen independently. So calling Qoli doesn't have to wait for the pizza delivery. So I can do that right away as soon as I order the pizza. So let's rewrite this. I'm gonna do everything the same as before, except I'm gonna add, right after I order the pizza, I'm gonna call my friend. Call Qoli. I hope he's all right. Haven't seen him in 6 months. Okay, so what happens when I do that? All right, I get the order the pizza, pizza was ordered, calling Qoli, but my pizza variable is still undefined. Because, as we discussed, there are still parts of my code that do need to wait for the pizza to be created, right? So like, for example, like eating the pizza, like this line. The last console log I have is part of my code that does depend on the function, the asynchronous function, the set timeout, because I can't eat the pizza before it's ready, right? So obviously pizza is still undefined. So we got to do something about that. Let's add another log. Let me rewrite this one more time. We're inside the set timeout. We can say console log pizza is ready. Actually, every time I write pizza, now I'm gonna do the variable, right? So that way we can see if it's actually changed or not. Pizza was ordered. Okay, so that's good. Let's execute this. And there we go, after 2 seconds. So let's go through this line by line. So same as before, we create the variable. We do have a function that we can call at any point. We call the function, the pizza is order pizza is called. The pizza was ordered. Then this line is called, which is still giving us the undefined. And then after 2 seconds, the pizza is actually ready. So to summarize, there's a function that's a little bit slow. We have parts of our code that depend on that function to finish before they can run, aka this eating of the pizza line. So one, we need to wait and be notified when the wait is over so that that line can run. And number two, we have other parts of our code, including the calling of the friend, that don't have to wait for the function at all. So we need a way to kick off that function and forget it and continue with the rest of our code. And that's where asynchronous programming comes into play. And the set timeout is a very basic example of that. Hold on, water break. Wouldn't it be great to shoot off the pizza order into its own process and not have to wait before it finished before we can do anything else? Well, that would be asynchronous. They don't happen one after another because they're not synchronized with each other. They are asynchronous, separate. Am I explaining this well? So if we take our road visualization from before, instead of the purple line going off to the side, it can actually keep going straight on the main road. And when we get to the async function, we start off a new road. So our pizza process starts and takes as much time as it needs to take. And almost immediately after we place the order, we can continue living our best life and calling our friend and doing the laundry and watching TV and writing code. And meanwhile, the pizza shop is making our pizza and delivering it, right? So how do we do this in code in a way that is not terrible? So the code we wrote from before is actually terrible. And here's why. Our order pizza function involves the eating of the pizza too. We don't like that. We don't want functions to do two separate things. In fact, this is called order pizza. It's not called order and eat pizza. So that's kind of a different topic. But the idea here is that we don't want this function to do two different things. We want it to just do one thing. But because of the asynchronous nature of the order pizza logic, we had to move some of that, the assignment of the value of pizza to pizza into that function. That's not good. One way to do this is using callbacks. We can say, hey, order pizza, do your thing, and let us know when you are done by calling this function that we're gonna give you. And we're gonna call this pizza ready. Back to the browser. Let me clean this up. Okay, so let's do our function again, order pizza by, I'm gonna refresh, okay. So order pizza now with our new setup is gonna take something called a callback, which is a function. It is gonna do what it was doing before, set timeout. We have an arrow function that takes 2 seconds, 20 seconds, 2 seconds. And then it's gonna call our callback, right? But it is also gonna do const pizza equals, how do we do this again? Our frequently used pizza, okay. And from here, I am also gonna do a function, pizza ready, which console logs. It actually takes the, wouldn't it be cool if we actually send the pizza to the pizza ready? Then we can say pizza, we can say eat the pizza. So by the time this is called, our variable is already set and we actually have to pass it into our callback, right? So now what do? Now we call order pizza. And we're gonna pass it the function pizza ready, which is a callback function, right? We say, hey, once you're done, call this guy. And then we can console log another one, which is as before, we can say call play, right? So what do we think is gonna happen? We're expecting to call our asynchronous function, which is order pizza. Well, this function itself is synchronous, but what happens inside it is asynchronous. And then we're giving it a function called pizza ready. So we're gonna pass the pizza ready into our, does this work? Nope. Ah, no, that doesn't work. So we're gonna say, I'm gonna pass pizza ready into order pizza as a callback. So do your thing. While you're doing your thing, we don't care, we don't wanna hear from you. Once you're done, call our callback. And by the way, this callback can be called anything you want. This is a local naming of inside order pizza. This will be called banana. And then we can say banana. So that doesn't need to be called callback. I like callback more though, so let's call that. And as soon as we order the pizza, then we're saying, I'm gonna call my friend and I'm gonna live my life. I'm not gonna wait for the pizza to show up, right? So let's see what happens. We called Oli, and after 2 seconds, our pizza showed up. In real life, obviously, not 2 seconds. That would be an incredible speed for any pizza shop. But the point is that we were able to call our friend and not have to wait for the pizza. And when the pizza was ready, then our logic was able to run, right? Again, this 2 seconds, it could be the 2 hours, could be 2 days. I mean, hopefully you don't have to wait two days for pizza. But the idea is that it doesn't matter. We're not, the response of our, the callback function that is really our reaction to the process of pizza making being complete doesn't know and doesn't care how long it takes. It just waits as long as it needs to. It knows it's going to be called by the order pizza function. And we can, like I said, go ahead and do what we need to do. We can do 10 other things. We can call our friend and do everything else, which is nice because it's not stuck waiting for the order pizza to finish, right? One can happen independently of the other, which means they are not synchronized. It's async. By the way, you might recognize this pattern of passing functions into each other from adding event listeners. So for example, if I add one to let me refresh, window.add event listener, let's say click, right? This is not uncommon to do this. And I can say console.log clicked. We're actually passing a function into our event listener, and we're saying we don't know when the user is going to click this button or this window in this case, but whenever they do, run this code. So this is actually another example of asynchronous code. So if I can actually rewrite this kind of similar to our previous function, say callback, right? And I can say my function callback does this. Oops, I already had that. Right? Here's my window here. I can click and it shows up, right? So exactly the same thing. So if you've ever used event listeners, you have actually used asynchronous code. So isn't that cute? So now there is one problem with callbacks, which you might have heard of, and that's what we call callback hell. So this is a problem that really gave birth to the concept of promises and async await, which we'll get to in a second. The problem is that if you have more than a few things that depend on each other, it can get kind of difficult to read. So let me show you what I mean. Imagine we have 3 things, right? So imagine the whole pizza ordering thing again. I have to call the shop, I have to wait for them to pick up the phone. Once they pick up the phone, I have to explain to them what pizza I want. So that's already 2 things that I have to do. So I have to call them, wait for them to pick up the phone, order the pizza, and wait for the guy to write it down or wherever. And then the third thing I have to do is wait for them to deliver the pizza, right? So just using that as an example, imagine we have 3 things that we have to do and one has to wait for the other. So I can say function, I'm just gonna call them simple stuff, thing1, and this would be call pizza shop, right? And then thing 2 is order the pizza. And then I can say call thing 3 is wait for pizza, or actually eat the pizza, because that would make sense. That would be like, I'm waiting for the pizza to show up. Piazza, right? So if I have these 3 functions and I want to create the callback sort of mechanism that I used before, it gets a little funky, and because they're all asynchronous. So let's start with thing one, for example. So I can say function thing one, I'm gonna rewrite that. Function thing one takes a callback, which is thing two, right? And I can say, once you're done, then call my callback. Then I'm gonna have to do the same thing for thing two and thing three. Again, I can call this callback, callback, callback. It doesn't matter because they're scoped within each function. But the point is, each of these functions take a callback and they're gonna call that function when they're done. So similar to what we're doing before. So how do I run this, right? How do I use these functions now? First, I'm gonna have to call thing one, and then I have to pass it the callback, right? So the callback I'm gonna pass it is thing, I'm gonna have to have a function that then calls thing two. Oops. And I have to do the same thing basically for thing two is I'm gonna have to say thing three. So here I'm saying once thing done is finished, I want you to run thing two. Once thing two is finished, I wanna run thing three. That's a mouthful, right? So I can do this. Whoops, I didn't pass a callback to function three. But this is the point I'm trying to make here. This callback hell. This is also called a sideways pyramid or something like that. It has another inverted pyramid. And remember, there's no logic here, right? This is the absolute simplest version of a callback hell that I can get to because there's literally no logic in my code. Now imagine each of these had their own 10, 20, 100 lines of code, and the way that we're gonna write this and the way we're gonna read it, it's very, very difficult. So we don't like this, right? And that's where promises come in. Promises are extraordinarily powerful, and understanding them is critical for navigating today's modern JavaScript because they're used everywhere all the time. So I'm actually gonna dedicate a full episode to promises, next episode, episode 12. But hopefully you understand the idea of synchronous versus asynchronous. If you have any doubt about anything I talked about, watch the video again or ask me below in the comments. I suggest you don't go into promises yet. There's a reason why I don't want to include promises in this episode. I want this to be just about the difference between synchronous versus asynchronous before you look at advanced code. And yes, promises are advanced. It's an advanced topic, especially if you don't fully grasp asynchronous programming. So to recap, when you have a program that runs one line at a time and each line waits for the next one, you are running synchronous code. And when you write code that spins off into its own direction, independent from the rest of your code, you're essentially writing asynchronous code. The most common example of async, I guess I could have mentioned this at the top of the episode, is data fetching, calling backend APIs and waiting for them to return some data. That's always a process that takes time. Calling backend APIs and communicating with other computers and servers always takes time, no matter how fast your computer or your internet is. And again, we're gonna get into that in episode 12. And I'll definitely show you some more realistic examples that don't rely on set timeout. And I guess in episode 12, we can cover promises and async await. Looking forward to seeing you in episode 12. Now go practice. And for those of you who are patiently waiting for the JavaScript Mastery course that I mentioned in the last video, you should know that it took me a while to write this episode because I'm working very hard on that full course and it's coming, I promise. Haha, promise. You can still sign up for early access on ColorCode.io, and I do see every sign up. I'm so encouraged by your interest and by your support, so thank you, and it's coming very soon. See you in a little bit.